Okay, so factoring and finding solutions on 21. If we were going to factor it, whoops, shouldn't have done that. First we need to find a factor. And we know since it's cubic that it has at least one real zero. And it would be ideal or good for us if it was an integer. That would help us out a lot. So we've got x cubed plus 5x squared plus 2x minus 12. You graph it, and that's how you find your first zero. So it looks like we've got two real ones. This one here doesn't go through a grid point, so let's check this one over here. And to do that, I'm actually just going to use the table, I think. I'm going to try to use the table. Oh, come on. It's at -3. My calculator will not respond, but it's at -3. So we know that we have a 0 at x equals -3. So there's two ways we can go about this. One way is with synthetic division, and I'll do that for this one. And we can do long division on a different one. But we get all our coefficients, 1, 5, 2, and -12. And then we start dividing. So bring down the 1, and then you do -3 times 1, and you put that answer right there. Then you add that column, 5 times -3, or 5 plus -3 is 2. Then you do -3 times 2, and you get -6. Then you add that column, and you get -4. And you do -3 times -4, and that's 12. Add that column, you get 0, which is what we want to get, because that means that x plus 3, so this becomes the linear factor x plus 3. And it means it really is a factor. It really does divide evenly. It's like dividing 10 by 2 and finding out that it's 5 right on the dot. Okay, so now what we have left is, what do we multiply x plus 3 by to get our original equation? And it's 1x squared plus 2x minus 4. Since we started with a cubic and we took out a linear term, we end up with a quadratic. X squared plus 2x minus 4. Now we have to do the part where it says find the solutions. Okay, so that's the fact we factored it, but we need the solutions. One of those solutions we already found from the graph, x minus 3. To get the other one, we need to know when x squared plus 2x minus 4 equals 0. So I'm going to complete the square because the leading coefficient is 1 and the middle term is an even number. And I like that. Okay, so I need to know what to put in the blank or the leftover spot after I move the 4 over. And that would be b over 2, 2 divided by 2, squared is 1. So plus 1 here and plus 1 here. Then we factor the left side. So factors of 1 that add up to 2. It's just 1. And that's equal to 5. Square root of both sides. So x plus 1 is over here is equal to plus or minus the square root of 5. Then we subtract the 1 over -1 plus or minus the square root of 5. And there are our other two zeros. Okay, jumping to number 23. It just says to divide, and so that could either mean long division or synthetic division. I'm going to do long division because I'm a glutton for punishment. So, how many times will r minus 7 go into r cubed minus 12r squared plus 28r plus 54? Alright, so with long division, you look at the first term in your linear factor. So r. r will go into r cubed, r squared times, I'm going to change to red, rojo, r squared. So r squared times r is r cubed, and then we have to do r squared times the other number, -7, and we get -7r squared. Alright, long division, after we do that, we subtract those things. R cubed minus R cubed is nothing. -12R squared minus -7, so that's plus 7R squared. Gets us -5R squared, and then we bring down the 28R. Then how many times does r go into negative 5r squared? Negative 5r. Okay, then negative 5r times negative 7 is 35r. And now we subtract that. We get no more r squareds, but 28r minus 35r is negative 7r. And we bring down the 54. And so now how many times will r go into negative 7r? Negative 7 times. That just means that negative 7 times r is negative 7r. Negative 7 times negative 7 is 49. And then we subtract that. And so we get 54 minus 49 is 5. Alright, that's our remainder. And if we have a remainder, it means that r minus 7 isn't a factor of that cubic. And so what do we do with it? Well, we know that the value of r cubed minus 12r squared plus 28r plus 54, if r equals 7, we know that the value of that, this whole thing, is 5. That's what we found out. That's its y value at that point. But we can write it still like this. R minus 7, r squared minus 5r minus 7. And then we have this other 5 that we couldn't divide by 5, or by r over r minus 7. So we have 5, and we still haven't divided that up by r minus 7. We tried, but we haven't yet. And so that's how you write it as a remainder. Or you could write it like this. R squared minus 5r minus 7 plus 5. That little pesky 5 that we couldn't factor out. And so just for fun real quick, I'll do that one with synthetic division because it is real quick. And I want you to see that when you have an integer as the 0, like 7, then synthetic division is the quickest way to skin this particular cat. Not that we would skin cats, but so you get the 5 remainder, and you get it a lot easier than all of the long division business. Okay, so there's 23, and it's just asking you to divide. It doesn't divide out evenly, and so we're stuck there because it's not a factor. If it was a factor, we'd set it equal to 0, solve for r, but it's not, and so that doesn't get us anywhere. So we just stop there. Alright, so number 25, I'm going to evaluate this using the remainder theorem. Okay, so if we said evaluate it at n equals negative 4, we would be saying find f of negative 4. And we know that that means when we come to n in the equation, we would put a negative 4. And if you try to do this in your calculator, make sure you put those all in parentheses. Okay. And that's a pretty extensive process. Not only that, but if you didn't have a calculator, you would have to do negative 4 to the 4th power in your head, negative 4 to the 3rd power, subtract them, a lot of messiness. Okay, and at the end of that, if you type it in, you would get f of negative 4 is equal to 6. Okay, and that's if you put it in your calculator. But the remainder theorem says the value of the function at negative 4 is whatever the remainder is when I factor it using synthetic division. So if I do synthetic division, I get a remainder of 6. And that's what I found as the value of the function at f of negative 4. So when n equals negative 4, the function equals 6. And you can find that out by doing all this, typing all that out, or you can just divide the function by negative 4 using synthetic division, and the remainder will tell you the value of the function at that point. It's a lot faster, the math is a lot easier, and you don't have to do negative 4 to the 4th power. So there's number 25.